Hey guys, welcome again to the Maths Club. We're going to continue on our series on fractions, decimals, and approximation. And now we're going to be looking at decimals and approximation. So without further ado, let's get started. Whenever we talk about decimal places, we need to know that whenever we have something like this, 3.728, the decimals start after the points, right? The first value is the first decimal place. The second value is the second decimal place. And the third value is the third decimal place. This is very important to know. In our place value, this is where the dot is. This is the beginning of to the right of the dot is where the decimal starts. So the first decimal is the tenths, second is the hundredths, third is the thousandths, fourth is the 10,000ths, and so on and so forth. Right? So you notice that there is a THS at the back of the 10 for decimal places. While for whole number parts, this for whole number parts, the first value there is the ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions. The reason why this first value in the decimal is the tenths is because to get that value, if I do 1 divided by 10, right, that is what? 0.1, right? So for me to get the first value in the decimal place, I have to be dividing by what? By 10. That's why it is the tenths. Right, it's the tenths. Great. With that being said, let's move to the next thing. So approximation. What is approximation? So it involves using simplified techniques to obtain an estimate that is reasonably close to the desired results. Right, so we want to get a value that is reasonably close to the desired result. So what is reasonable is really dependent. Some people say maybe to the nearest 100, to the nearest 10, to the nearest 1, right? Some people say to the nearest hundredths, right? That is reasonable to them. So the term reasonable is very subjective, right? But that is by the way. So it says numbers can be rounded off to the nearest 100, 10, whole number, or to a given number of decimal places. So if I have the digits 1, 2, 3, 4, right? Digits 1, 2, 3, 4 are rounded down, and digits 5, 6, 7, 8, 9 are rounded up. So we're going to see all of these things really come out in real examples. So let's continue. Now we're given this example. We're told to round off 163.864, right? 163.864. So the first part that we're going to do is to 2 decimal places. So if you have 163.864, so this one says to 2 decimal places, right? So this decimal place 1, decimal place 2. So this is where they want us to end. The value after the number 1, what did they say about values 1, 2, 3, 4, values less than 5? They said values less than 5 are rounded down, and values greater than or equal to 5 are what? Are rounded up. So in this place here, our value is what? Our value here is 4, right? So it's going to be rounded down to 1 decimal place, dp. Our value will just be, sorry, is it 1 decimal place to 2 decimal places? To 2 decimal places, our values will just be 163 point what? 0.86. So this is it. Or we can say 860 because we're going to round this 4 down, right? We're going to round it down to 0. Right? So this is basically it. Let's see if we're correct. Yeah, 163.86. Yeah. So the next value is saying to 1 decimal place. So to 1 decimal place, right? This is decimal place 1. They want us to only leave 163 point something, right? Now we have to look at the value that is just after it. The value that just after it, is it up to 5? Yes, it is. So it is what? It is 6. So we're going to round up this guy. So we're going to give the 8 here. We're going to give it an increment of 1, right? Because we're going to round up. So that will be 163 point what? 0.9. 0.9 because the guy that is after it is greater than or equal to 5. So you can see we only take note of the value that is just after the value that we want to round up or round down. So that's 163.9. Great. So this one says to the nearest whole number. So the nearest whole number part, a number is divided into two parts, right? So we have the whole number part, which is this guy, and the decimal part, which is this guy. So you only want to see this whole number part, right? So all we just need to do is we have to look at the first value in the decimal part. Is the first value in the decimal part up to 5? Yes, it is 8. So because it's up to 5, I'm going to add 1 to the last value of the whole number part. So I'm going to increment this 3 to 4. So to the nearest whole number, that will be 160 what? 164. Great. And they now said the next one is to the nearest 100. Let me see, is it 100 or hundreds? Okay, it's the nearest 100. Now, we know that this is the ones, right? This is the ones. This is the tens from what we saw. And this is the hundreds, right? So it's telling us to the nearest 100. So you only want to see, this is 163. So you only want to see maybe 100 or 200, depending on the value that is after the 100 or the value that is in the tens place. Now, the value that is in the tens place, is it up to 5? Yes, it is, right? So because it's up to 5, I'll carry over 1 to this one. That will be 1 plus 1, which is what? 2. So that means to the nearest 100, this value is actually what? 200, right? So that's just basically it. Let's see if we're correct. Great, so correct. So just always note the value that is after the points that you want, and you need to know if they say nearest tenths, right? You need to know that they're talking about the decimal part, right? So just know the difference between the terminologies. Great. So that's basically it about this. Significant figures. From the word significant figures, that means the figures in a particular, or the digits in a particular number that are relevant, right? Significant, relevant. So these are some of the rules of significant figures. So the first rule says all non-zeros are significant. So if you have a number, let's look at an example. If you have a number, right, so you can see 0.345, 123.34, 42.25. All non-zeros are significant. You can see. So when we count significant figures in this one, this is 1, this is 2, this is 3, right? So you can see 3. This is 5, right? This is 3. So all non-zero digits are significant. That is the first truth. The second truth is zeros that are sandwiched, right? That means that are in between non-zero digits are significant. So if I have 101, that 0 in between the 1 and the other one is a significant digit. Let's see. So this example, we have 4205. You can see the 0 is sandwiched in between 2 and 5, right? That's why we have 4 significant places. These zeros too, you can see there is a 2 in the decimal place after the zeros, right? So you can see we have 5 decimal places, and you can also see the same thing for this other guy. We have 7 significant figures here. Now, it says zeros that come before all non-zero digits are not significant. Zeros that come before all non-zero digits. So in the case where we have 0101, that 0 at the front is not significant. So let's look at another example. So look at this. We have 0.32. You can see this 0 here is not significant. The significant figure starts from the non-zero. You can see same thing too. But look at this one here. The zeros here are not significant, but the 0 in between the 2 and the 4 is significant. That's why we have 3 significant figures. This guy says zeros after non-zero digits within a number without decimals are not significant. Let's see what it says. So look at this. Zeros after non-zero digits. So this is 3, 4. You can see the zeros after it, right? Without decimals are not significant. You can see this is there a decimal in this place? Is there like 0.2 something? No, right? So all these zeros, they are not significant. So you can see what they said. Zeros after non-zero digits within a number without decimals are not significant. But look at the last part. It says zeros after non-zero digits within a number with decimals are significant. You can see this is a flip scenario. So you can see after these non-zero digits there is 00, but there is a 2 after. Right, those zeros are actually significant. That's why we have 10 significant figures. So it might take a bit of back and forth to really understand all of these things, but once you understand them, you will begin to fly. So that's basically it about the rules of significant figures. And if you see this particular image, you can see there are zeros right before so all these zeros are not significant. This is the first significant figure, second significant figure, and third significant figure. Great. So let's look at some examples. So it says round off 146.83. So 146.83 to one significant figure. What would that be? Right, I just want only one. And if you look at it, so there's something that I meant to. So this one here is the most significant. This is the second most significant, third most significant, fourth, and fifth. So if they want one, they're asking to leave it at the most significant, and which is this guy. So the next guy after is it up to 5? No. So it will be 100 to one significant figure. So it will be 100 to one significant figure. So to two significant figures, it will be these two. So it will be the most and the second most significant. After the second significant, the value is up to 5. So that will be 1 what? Great, you got it. 150 to two significant figures. Let's see if we're correct. Great. So three significant figures, right? Do you want to try that? Great, you got it. So that is 147 to three significant figures, and then the last one is to four significant figures. So that will be most, second most, third most, and fourth most. The fourth, the guy after the fourth most is not up to 5, so that will be 146.8 to four significant figures. So that's basically about rounding off numbers. Now let's look at more examples. So this guy says that we should round off the number 0.002487. We have 0.002487, right? So we want to round it up to one significant figure. We know that for this type of things, all these zeros are not significant. So the first significant figure is the first value after the zero. So to one significant figure, because that will be looking at this 2. The next value after 2 is not up to 5, so we're not going to consider. We're going to round it down. So to one significant figure, that will be 0.002 to one significant figure. Let's see. Great. So to two significant figure, that will be 0.002 what? Because the value after the second one is more than 5, so that will be 5 to two significant figures. Great. So to three significant figures, that will be 0.0024. Now this is the 8th part, right? The value after the 8 is up to 5, so I'm going to add 1 to the 8. That will be 249 to significant figures. Right, so that's basically it about it. Now let's look at this last portion. So it says that given that x is approximate, so when you see this sign here, this wavy equal to, it means approximately. Right, approximately. Given that x is approximately 0.0102 correct to three significant figures, which of the following cannot be the actual value of x? Right, so let's see. Let's start from option D. You can see this is 0.01016. So to three significant figures, let's convert to three significant figures. This is significant figure 1, significant figure 2, significant figure 3. The value after D1 is up to 5, so of course D can be x. So that's not what we're looking for. We're looking for the one that cannot. This one too, we have 5, so this can be. This one we have 0.01021. If I'm looking for 3 decimal places, this one here is not up to 5, right? So I'm not going to add it to this 2. So this one can be, right? Because by the time I do it, that will be 0.0102. So this guy here, so we have 0.01014. The guy after D is not up to 5, so I'm not going to be adding. So this option A cannot be the actual value of x, right? So our answer is A. So with this, we've actually come to the end of decimals and approximation. So the next time that we're actually going to meet, we'll be looking at past questions that contains fractions, decimals, and approximation. See you guys in the next video.